Hello friends, welcome to SnR Academy, your online coaching portal for GATE and IES 2018. Friends, welcome to the Communication Systems Lecture 3 today. First of all, I would like to apologize for the little delay that we have from Lecture 2 to Lecture 3. But friends, this is how it is going to be. From now on, I'll upload lecture on alternate days. So you can find the next lecture on every alternate day. So you can use that time, the one day you have, to go through the theory and solve some problems on that, and then we can continue because you have enough time for the exam. So I just posted two lectures at once because I wanted to know your feedback. So I got to know that a lot of you have problems in this subject, communication systems. So I would cover this subject in complete detail. We will go slow, we'll keep solving questions on each and every topic we discuss. So I'll take care of the fact that if you're not too good at the subject, we'll solve some easy questions and then we'll try to increase the level slowly. So friends, let's begin the lecture 3. And today lecture 3 will be about, we'll discuss amplitude modulation today. So in lecture 1 and 2, all those who have not watched lecture 1 and 2, I discussed about modulation, and I discussed the basics of signals and systems which would be used in our discussion today. So friends, today let's begin with amplitude modulation. So first of all, I'll just give you the brief that what we discussed. So we already discussed modulation, and I already told you what is modulation. So modulation is basically shifting of the lower frequency spectrum to some higher frequency to reduce the antenna height and to get the advantage of multiplexing. So now modulation, today I'd like to classify it in two types before starting with AM. So first would be like single tone modulation. So what is single tone modulation? So single tone modulation is like if you have a message signal which you are trying to modulate. So if your message signal, say MT is your message signal, and it is this kind of a signal, AM cos 2 pi FMT. So if I say this, if I see in this signal has just one frequency component, that is your FM. So if I try to draw its frequency spectrum, you will just get one impulse function at FM. So this is called single tone modulation because you have just one frequency component in the spectrum of the message signal. So whenever we are trying to modulate the message signal with one frequency component, so just remember that it would be called single tone modulation, and it is defined with respect to the message signal, not the carrier. So your message signal should have one frequency component. Similarly, second part would be multi-tone modulation. So you can already guess what this is. So multi-tone modulation, the message signal can have two or more number of frequency components. So if I want to write my message signal as, say, AM1 cos 2 pi FM1t plus AM2 cos 2 pi FM2t. So you can see it has two frequencies in the spectrum, FM1 and FM2. So that's why it would be multi-tone modulation. But also remember that it can have more. So if I have a message signal which has a spectrum like this, which is going from, say, 0 to FM. So it has all the frequency components from 0 to FM. So this, if you're trying to modulate this signal also, then also it would be your multi-tone modulation. So multi-tone modulation, it can have two or any number, more than two, any number of frequency components. So that is your multi-tone modulation. So we will start with single tone modulation because mathematically understanding the single tone modulation is more easy, but in practical sense multi-tone modulation is used. So we will discuss single tone modulation and we can just extend that concept to multi-tone modulation. So that was the two types of modulation we can have. Now let's begin with the topic today, amplitude modulation. So as the name suggests, what is amplitude modulation? What is modulation? First of all, modulation is changing some property. So what property we are going to change here would be the amplitude of message signal. So if I'll show you the curve in the time domain, you will see that the amplitude of the message signal changes with time. So that's why it would be called amplitude modulation. So we'll see that later. So let's discuss its mathematical form. So as I told you that in modulation, when you have modulation, you need to have a carrier signal. So carrier signal is the one which would be modulated by the message signal. So if I say the carrier signal is AC cos 2 pi FCT, so this is our carrier signal, and we will take the message signal as MT as, let's first talk about single tone modulation only. So we will take it as AM cos 2 pi FMT. Now friends, this is your message signal now, or it can also be called as modulating signal. You will come to know why it is called modulating signal, basically because it is the one that is modulating the carrier according to itself. So this one is the modulating signal. So this is a thing to remember, don't get confused. So the message signal is itself the modulating signal. Now if I want to write the general expression for AM, I can write it as, so this is just an expression for AM, I can write it as AC 1 plus KAMT, so MT is your message signal, cos 2 pi FCT. So this expression is important. If you can remember that, that would be very good. So just highlight this. So now you can see in this expression what is happening is AC cos 2 pi FCT is your carrier signal itself. But now if you see the overall amplitude of this AM signal, it is given by this factor AC 1 plus KAMT. So as the value of MT changes, this 1 plus KAMT factor changes, and this entire amplitude part changes. So now you can understand how this MT signal is affecting the amplitude of the carrier signal. So now this overall signal is called the amplitude modulated signal, or your AM signal. So that's why we are calling this MT as the modulating signal, because it is modulating the overall amplitude of the carrier signal, and that is how you are getting your AM output. So I'll just now expand this expression. Let's just do a few mathematical steps here. So if you have understood this, it would be easy. If you remember this expression, it would be easy for you to understand the rest of the part. So now I'll just expand this. I'll just open the brackets of the above expression. So I can write it as AC cos 2 pi FCT plus AC KA MT cos 2 pi FCT. So now if you see, what is this part? It is the carrier signal itself. And if I write this part, then this is again your carrier signal. So it becomes KA MT into CT. Right? And what is KA here? It is just a value which is also sometimes it will be referred as amplitude sensitivity of AM. So no need to remember this. This Ka is just a factor here. So now if you see what your AM has, it has two components. So first is it has the carrier signal itself, and then this is your modulated signal part. Because if you remember, I told you when you multiply something with a cos function, that is how you do the modulation. If you multiply with cos 2 pi FCT, the entire spectrum will shift to FC instead of 0 now. So now this complete part KAMT into CT, this is your modulated signal. So AM, it has your original carrier plus the modulated signal. So that is how your AM looks like. So let's say I'll take a message signal now, and we will try to sketch its spectrum keeping this expression in mind. So let me assume MT to be having a spectrum like this. So it has some 0 to FM and minus FM. And how our carrier would look like, we already know it is a cos function. So it is going to look something like this. It will have two impulse functions of areas AC by 2 at the frequencies FC and minus FC. So before moving ahead, let's see the bandwidth of the message signal itself. So if you see, the message signal extends from 0 to FM, so the bandwidth simply becomes FM, the maximum frequency component minus the minimum frequency component, that is FM minus 0, you get FM. So the bandwidth of the original message signal is FM. Now now if I want to sketch this one, Ka empty CT, so let's forget this Ka for some time because this is just a constant. So how would your empty into CT look like? So empty into CT, we know this is the modulation property. If you multiply something with cos, your spectrum gets shifted. So now if your original spectrum was centered about origin here, now instead of origin it will move to frequency FC, and similarly on the left hand side it would be minus FC. So this frequency now becomes FC plus FM, this frequency becomes FC minus FM. Similarly you can write it here as minus FC plus FM, minus FC minus FM. So this is how your empty into CT signal looks like. Now what was your AM signal? So AM, you already saw, it is the modulated signal, that is your empty into CT plus the carrier signal, which is this thing. So now if I want to sketch the overall amplitude modulated signal, your AM signal, I can sketch it like this. So you get your modulated signal plus you also get the carrier which was at frequency FC. So this is again FC plus FM and FC minus FM. Similar thing on the left hand side. So again, what is the difference between these two? You are just getting this carrier signal at the frequencies FC and minus FC. So now this is your spectrum of the amplitude modulated signal. So now if I want to analyze the bandwidth, now I can see that this signal now extends from FC minus FM to FC plus FM. So if I subtract this highest frequency component and the lowest frequency component, I'll get the bandwidth. So if you subtract this, you will get 2 FM. So what we observe here is, when we amplitude modulated our original signal, what we got the bandwidth, the bandwidth got doubled in the process. So from the original message signal bandwidth FM, the amplitude modulated signal has the bandwidth 2 FM. So this is how your AM spectrum would look like, just to get an idea how AM works. Now let's discuss something about the single tone AM. So this part would be mostly mathematics. So you have to remember the trigonometric identities part that I already discussed in the first lecture. You need to use some properties here. So because now this is a single tone AM, so you can say that the message signal will have only one frequency component, and I am assuming it to be AM cos 2 pi FMT. So and your carrier signal I am assuming to be AC cos 2 pi FCT. So friends, one thing also you should remember is, when you are doing modulation, you should know that FC is much greater than FM. That is why then only you can shift the spectrum to some higher value. As I already told you, you want to shift this entire spectrum from 0 to a higher values, so you can reduce the antenna height. So FC should be much greater than FM, because if it does not happen, you will get the spectrum somewhere here. So you'll get some spectrum like this, which you don't want, because you will have the zero frequency component, and your antenna height would be practically infinite, which you can't get. So FC would always be much greater than FM in case of any modulation, if you see. So now let's write the expression for AM. So expression for AM we already wrote. So we know it is going to be 1 AC 1 plus KA MT. Now I am going to put the value of MT here. That is AM cos 2 pi FMT cos 2 pi FCT. Now I am going to define a new constant here, that is the value of KAM. I will define it as modulation index. Now this is the important part. So this modulation index, this is how it mentions in the questions. So this would be, when you are specifying AM, you have to give the modulation index. What is the value of modulation index? So what is mu here is basically it is your Ka into AM, the maximum amplitude. So I can also write mu as Ka into maximum value of MT. So in this case it's AM. So the your modulation index becomes Ka AM. Now this modulation index, whenever it is specified in a value, that would be called modulation index. But if I define it as a percentage form, say if my modulation index is say 0.6, so if let's define it as 60%, then it can sometimes also be called as depth of modulation. So depth of modulation or modulation index are specifying the same thing. So these are the two terminologies that can be used, and it is very important to understand this modulation index to understand AM. So remember how we define the modulation index. Now based on this mu, we can have three types of modulation, which all I'll discuss the three types later on, but let's just go over them. So mu value can be less than 1, mu value can be equal to 1, or mu value can be greater than 1. Mu value less than 1, it is called as under modulation. Whenever mu is equal to 1, it would be critical modulation, and when mu is greater than 1, it is called over modulation. And also I'll discuss this again in the future. So mu less than equal to 1 is preferred when to have demodulations, to have simple demodulation. So once we enter demodulation of AM, you will understand how mu less than equal to 1 will give you a simple demodulation circuit. So just remember this for some while. We'll discuss it and we'll understand the details later. So now let's focus on the equation again. So the equation was this one, the AM expression. Now I'll just expand it. So again I'll just open these brackets here. So I'll write it as SAM of t would be AC cos 2 pi FCT plus AC KAM. I'll not write KAM this time. I'll use instead of KAM, I will use mu. So mu cos 2 pi FMT into cos 2 pi FCT. So now we'll use the trigonometric identity cos A cos B, and we'll change this product of cos to sum of cos terms. So remember the trigonometric identities that I discussed in the first lecture. Let's just apply it. So I'll write it here down as AC mu. This would become, so cos A cos B becomes cos A plus B plus cos A minus B by 2. So I'll just take the 2 factor here. Cos A plus B would be cos 2 pi FC plus FM into T plus cos 2 pi Fc minus Fm into T. So this becomes your expression now. So now this part you can see it is your carrier signal. And now let's just see these two parts. So one is Fc plus Fm, one is Fc minus Fm. So Fc plus Fm, this is higher than Fc, your original carrier frequency. So because this is higher than Fc, I'll call this part is called as upper sideband or the USB, and this part would lie before the carrier frequency Fc. So this part would be called the lower sideband. So it becomes more clear when we draw the spectrum of the above mathematical expression. So let's just take the spectrum here. So if this is your 0 point, so you know how the AM structure looks like. So you will have carrier frequency component because of this part. So this is your AC by 2 at Fc. Similarly AC by 2 at minus Fc, and then the modulated signal part. So one part upper sideband, it is coming at Fc plus Fm. So you will get Fc plus Fm here. So this is your Fc plus Fm. What would be its value? I told you already, when you are multiplying with cos, just split the signal into two and put it at the two parts. So if this was AC mu by 2, the amplitude original, now it becomes AC mu by 4. So similarly on the other side you will also get this AC mu by 4 at minus Fc minus Fm, and then this lower sideband which is Fc minus Fm. So it would lie before Fc. So this would come somewhere here, Fc minus Fm, and this side it would be at minus Fc plus Fm. So this magnitude is again AC mu by 4 or AC mu by 4. So this is your spectrum of the single tone AM expression that we took. So this is how you can sketch the spectrum. See, originally we need only this part to define the bandwidth and other things, the right hand side of 0, but you should always have the habit of drawing the left hand side part also, because if you do a further modulation, then these parts become important. If you miss this, you are certainly going to miss the further steps if you are solving a question one more step ahead of this. So always make it a practice to sketch the spectrum on both the sides. So now I'll just so let's just find the bandwidth of this also. So bandwidth, again you know it, the formula to find the bandwidth. You can see the lower frequency at this part and the maximum frequency at Fc plus Fm. So you can see the bandwidth now becomes 2 Fm, which you already saw, and I told you that it becomes twice the message signal bandwidth. So the AM bandwidth is twice the message signal bandwidth. So just remember this as a formula. The bandwidth of the message signal, the bandwidth of the AM signal, is twice the bandwidth of the message signal. So let's just take a quick revision here now. So what all we discussed. So modulation, we discussed the types of modulation, the single tone and the multi-tone. Then we discussed the amplitude modulation part, where you have to remember this AM expression. It's very simple to remember this. It has a carrier component and a modulated signal component. Then we saw that the bandwidth of the message signal, bandwidth of the AM signal becomes twice the bandwidth of the original message signal. Then we saw the expression for the single tone AM. We defined the term mu. Now this is again an important part. Mu, the formula for mu and what is mu, the understanding is very important. Then the three types of modulation, which we will see again later, and then we understood what the components of the AM for single tone modulation, the carrier frequency, the upper sideband, and the lower sideband. So this part is also important. You have to understand that AM has a carrier component, upper sideband and a lower sideband, and then again the same formula that we got, bandwidth is twice the message signal bandwidth. So these were the few parts of AM. Now moving ahead, we found out the bandwidth. Now we also want to find out the power of AM. So let's find the power of AM. So here we already know that AM has three components. So if I add the power of all the three components, I get the total power of AM, which is PT. So what are the three components? Your carrier component, the upper sideband and the lower sideband. So in the above figure, in the spectrum that we drew, we can see this is the carrier component, this is the upper sideband, or we can write it down here. This is your upper sideband, this side, this would be your upper sideband, and these two would be your, and this one is your lower sideband. So if you see the expression now, you got AC cos 2 pi FCT. So what is this AC value here is? AC is the peak value of here of this signal. So if you want to find its power, what you have to do, you have to simply use, what is the formula for power? Power is basically VRMS square by R, right? So this is the peak value. So if you find the RMS value would be AC by root 2. So RMS square becomes AC square by 2R. So this is your power for, if I define the power for this carrier signal. Now if I want to the power normalized with respect to resistance, I'll just keep R equal to 1 ohm. So the power becomes AC square by 2R. So similarly you can also find it here also. You see what is the magnitude here of the upper sideband and the lower sideband signals? It's AC mu by 2. So this is a peak value. You can find the RMS value. If you find the RMS value, it will be becoming AC mu by 2 root 2. So if you want to find out the power, so power would be simply RMS value squared by R. So it would be AC square mu square by 8R. So this is the power of your upper sideband. Similarly, same power you will get for lower sideband. So this power, it is equal to the power of upper sideband or the power of the lower sideband, and this one which we found here, it is your carrier power. So I'll just normalize it with respect to resistance and keep R equal to 1 ohm. So let's just substitute these values here in the expression here. So PC we found out AC square by 2 normalized with respect to R, keeping R equal to 1 ohm. This one we found out as AC square mu square by 8. Similarly the lower sideband also was AC square mu square by 8. Now just add those two terms and take AC square by 2 common. So this one you will get 1 plus, so this one if you take AC square by 2 common here, if you add these two, you get AC square mu square by 4, and take this part common, you will simply get here mu square by 2. So this is your total power for AM. This is again a very important formula for numerical questions. So I can also write this formula as, because you know AC square by 2 again here is the carrier power itself, so I can write it as PT equal to PC, the carrier power, to 1 plus mu square by 2. So you can make a few conclusions from this expression that I got here. So you can see, since this term is 1 plus mu square by 2, so you will always see that the power of AM would be greater than the carrier power, and as you increase mu, the total power of AM will increase. So the more the mu, the more would be the transmitted AM power. So also you should remember this expression, plus you should also remember the power expressions for each and every term. So the carrier component power was AC square by 2, the upper sideband and the lower sideband power was PC, sorry, not PC, it would be, if I take this term, so this is your carrier power, so the USB power and LSB power, or let's just do it this way, you can write this PT as PC plus PC mu square by 2. So you know this is the carrier power, so this power has to be the total sideband power. So total sideband power, it is your upper sideband power plus lower sideband power. So you can say that the sideband power would be, total sideband power would be PC mu square by 2, or the power of each sideband would be, so you know that both the components will have same power, so it would be PC mu square by 4. So this is your first formula. From here you can always remember PC, the total sideband power, and the upper sideband and the lower sideband power. So if you just remember this total power formula, that means you already know all these terms. So that is part of your AM power. Now let's just try to put a few values here and just see the cases. So if I take mu equal to 0, so case 1 would be mu equal to 0, that is your no modulation. So using the same expression above, if we have no modulation, the mu equal to 0, then PT is simply equal to PC. That means you are transmitting the carrier power itself, no additional power, that is you are not doing any modulation. Second case, if I take mu equal to say 1, that would be your critical modulation, as we know the name for it, critical modulation, the PT becomes PC 1 plus 1 by 2, that is your 3 by 2 PC. So you are basically transmitting 1.5 times the power of the carrier signal. So you are transmitting 50% more power than the original carrier power. So you can similarly, as you'll keep on increasing mu, this PT will keep on increasing. So now let's just separate the powers here. So that case mu equal to 1 only, we'll keep that same case. So what is your carrier power in this? So carrier power is PC. So the sideband power would be total power minus the carrier power. So total power is your 1.5 PC minus PC. So 0.5 PC is your sideband power. So your sideband power, you can say it is, because your total power is 1.5 PC and it is 0.5 PC, so you can say it is 1/3 of the total power, or 33.3% of the total power is your sideband power. So now friends, if you see, the carrier part is the part we do not require actually, because your carrier does not have any information. The main purpose of modulation is to transmit the message signal, not the carrier. So the power which you are transmitting in form of carrier is actually a wastage of power. So the sideband power, it is what is the required power and what is the useful power, because if you see the spectrum here, you see the modulated spectrum, that is only your sideband. So your original carrier signal is never contains any information of the message signal. So sending the carrier is a wastage of power in this case, and you know in AM we are sending the carrier. So if you see here, the sideband power, or you can say it as the useful power now, because you know that the most of the information of the message signal would be stored in the sideband, and the carrier does not have any information regarding the message signal. So the useful power is your only 33%. So if you are sending 100 watt of power, only 33 watt is the useful power. So that becomes a disadvantage of AM. You can classify it as a disadvantage. So the first disadvantage of AM we saw was that the bandwidth becomes more, bandwidth becomes twice. So the bandwidth, always we want to keep the bandwidth as minimum, because in communication we are transmitting through wireless system. The bandwidth is the most costliest part. So the trying to optimize the bandwidth, keeping it to the minimum possible, is what we will want to design our system in a way that it takes minimum bandwidth. The more bandwidth it will take, it will increase the cost, it will decrease the number of users it can accommodate. So bandwidth you will always want to keep minimum, but AM you are seeing it becomes twice, or it increases. And the second disadvantage we saw just now, that the useful power is very low, or there is wastage of power in form of carrier. So if you are transmitting the carrier, you are certainly going to have some wastage of power, because that is not the useful part. The useful part is only the sideband power. So now we can define a term which would be called power efficiency. So power efficiency, the same thing, because there is some useful power and there is some waste power. So efficiency, you will define it as useful power upon total power, and useful power, you know, it is going to be the total sideband power. So PSB by PT, that becomes your useful power, or the power efficiency, sorry. So PSB by PT is the power efficiency. So we know PSB, the sideband power, is PC mu square by 2, the total sideband power, and the total power is PC 1 plus mu square by 2. So cancel the PC here, just do some calculation and make it mu square, and cancel the 2 also. So it becomes mu square by 2 plus mu square. This becomes your power efficiency. So in this case you will see, if you increase mu, your efficiency will keep on increasing, because if you know mu is equals to 0, we will get sideband power as 0, so efficiency would be 0. If you keep mu is equals to 0.5, you can calculate it, you will get efficiency of around 11%, and then mu is equals to 1, we already saw, we got the efficiency of 33%. So now an important note here, the note is that you should remember that PC is always independent of mu. Why? Because PC, the total power would depend on the modulation index factor, but the carrier power, it never depends on modulation index, it is always constant, and it is given by AC square by 2R, and your total power is the one that depends on mu, because you have this factor mu square by 2, or the sideband power also depends on mu. So basically when you're saying your efficiency is increasing, so you have to say that your sideband power is increasing. Also total power will also increase because the carrier power is always constant. So when you are increasing the efficiency or you are increasing the modulation index, you will see that the sideband power and the total power increase, but the carrier power always remains constant. So this is a point to remember for future. So this is the power efficiency part of AM. So friends, this lecture I will cover till here only. From the next lecture, or we can just I'll just give you two more formulas here, which are just the deduction from the power formula that we got. So just we can just note it down as well at the and then I'll finish this lecture here. So now we saw the power relation in AM. Now just see current and voltage relations of AM. The current and voltage relation. So it is, I am just concluded from the power formula itself, because power, the power, you know, it is proportional to the square of the current or the square of the voltage. So I can say current is will be proportional to root of power, or voltage would be proportional to root of power. So if I want to define total current instead of total power, now I want to define total current. Just a second. So total current, that is IT, you can simply say it would be IC. Now instead of 1 plus mu square by 2, you will get root of 1 plus mu square by 2, because of I being directly proportional to root of power. Similarly, you can say the total voltage would be VC 1 plus mu square by 2. So these are just two more formulas, but the more important one is the power formula. So if you remember the power formula, you know that if you square root this value, you will get these relations. So again here, this IC and VC, these would be independent of mu, and your total one, IT and VT, would depend on mu. So always remember this and don't get confused with this. So friends, that is, now I'll finish this lecture here. So we discussed AM, we discussed the bandwidth of AM, we discussed the power relation of AM, and we deduced the current and voltage relations, and we also drew the spectrum of AM. So you should have an understanding of AM, how is AM working, what are the important terms and the important formulas that you have to remember, and you have to take in your notes. So now, just to finish this lecture, let's just go over some questions now. So the questions today will be very easy, but as I found out that some of you have problems in understanding the subject, so it is better first we solve the easier questions, the level 1 questions, before moving to the next level. So let's just look at question 1 now. So these are very simple questions based on direct formula. You can find these. So the question 1, what is question 1 saying? Question 1 says, for an AM the total sideband power is given. So write it down as PSB, the sideband power is given as 100 watt, and mu is also specified as 0.5. Now it is asking you PC and PT. So we know the power relation, we know the sideband power also, it is PC mu square by 2. So from here, if you substitute these values, simply put the sideband power as 100 watt, PC is what you want, mu is you already know, so that becomes mu square 0.25 by 2. So just solve this. So your PC comes out to be 200 divided by 0.25, that is your 800 watt. So if you have found out PC, then you know that PC never changes, it is always constant. So you can say PT equal to PC 1 plus mu square by 2. Again substitute these values here and you can find out the total power. So again I'll just repeat that point. So if there was a second part in this question, say if it asked you to find out the total power, or let's say there was a second part as same as the first one, it is again asking you to find PC and PT for mu is equals to 1. So you can directly say that because you know that carrier power does not depend on modulation index, so you don't need to find carrier power again, carrier power would remain same. So the carrier power will now be same again, it would be again 800 watt, but the total power would change, that would be your 800 1 plus mu square by 2, so 1 plus 1 by 2, so 3 by 2 into 800, so that becomes your 1200 watt. So this would be your answer. So just emphasizing the fact that PC does not depend on the modulation index. When it was 0.5 or it is 1 or let it be any other value, it will always be same for all the cases. So this was the question 1. Now just take a look at question 2. Try to solve it by yourself. From the lecture we have discussed, you should be able to solve it very easily. So now what this question says, a carrier signal of, so carrier signal is specified. So your carrier signal is given as 10 cos 2 pi into 10 to the power 6t, is amplitude modulated by a message signal 6 cos 4 pi into 10 power 3t. Find all the parameters of AM. So simply it is asking you to find the bandwidth, the power, the efficiency. Those are the 3 parameters that we studied today. But first of all, let's note down what is given in the question. So in your question it is given a carrier signal, so the carrier frequency is 10 to the power 6 hertz or 1 megahertz. Your message signal is also given, so message signal frequency is given as 10 to the power 3 hertz or 1 kilohertz, and your AM and AC are also given. So AC is your 10, AM is 6. So as you know that to find any parameter of AM, you should know the modulation index, that is the most important parameter. So you know that you have to find the modulation index mu, which we defined as KAAM. But in this question Ka is not specified. So how to deal with this question? So that is why I put this question here. So remember that if Ka is not specified, you will take Ka as 1 by AC. So then the modulation index mu simply becomes AM by AC, which is like 6 by 10 now, which is 0.6. So this was the main motive behind discussing this question, to let you know that if mu is not specified, how you can find it out. So now if you know mu, it's very simple to find anything that you want. So find out, let's say first find out the carrier power. So carrier power, you know, does not depend on mu, it would be AC square by 2R, and R is normalized to 1 ohm, so because it's not specified, so we'll take it as 1 ohm only. So AC square by 2, what is your AC? 10, so it becomes 100 by 2, it becomes 50 watt. So now you have, since you have found out the carrier power, you can find the other terms as well. You know the relations, you know the total power is PC 1 plus mu square by 2. So simply put the values, I'm not solving it here, You can put the values and find out the value here, and then you find out the sideband power, that is PC mu square by 2, or you can also do PT minus PC. You will get the same thing from both the cases, and then you can find out the efficiency as PSB by PT. So that is your basic formula how to find the efficiency, but if you remember the formula we discussed, so you can also find it by mu square by 2 plus mu square. So it's your wish how you want to solve it. If you don't want to remember this formula, you can use the basic definition of efficiency, otherwise just go for the formula and get the answer directly. So that was your second question. Now let's look at the third one. So third one says your AM signal is given by, so it has given you the AM signal itself. So the equation it is given, this ST now is your AM signal, so it is S AM of t. So the AM signal is specified. So it says 4 cos 3200 pi t plus 10 cos 4000 pi t plus 4 cos 4000 pi t, and now it is asking you to find all these parameters. So what you can find out from here is, because it has given 3 terms, so if you remember, what would be the 3 terms? One would be your carrier, one would be your upper sideband, not power. So the 3 components would be carrier, upper sideband and the lower sideband. So from here you can conclude that, so okay, there's a little bit mistyping here, this one should be 4800. So now if you compare it to this equation, you can see that the central one would be the carrier, because that is how you get the spectrum. You get the carrier here at FC, then at FC plus FM and FC minus FM you get the sidebands. So the central value, what is the central value here? You can say it is 4000 pi t. So the FC would be 4000 pi divided by 2 pi, that is your 2000 hertz. And you can from here you can say that FC minus FM is your 3200 pi, or you can say it is 1600 hertz, or you can also say FC plus FM is your 4800 divided by 2 pi, that is your 2400 hertz. So from both these equations you can find out FM. So FM would be coming out as 400 hertz. So this question, it just tells you that if there is a AM equation given, how to get all the parameters of AM, how to first of all get the carrier frequency, message signal frequency, and then you can find out. So this is since this is your carrier component, you can also find out AC. So AC is, it is saying 10, and if you remember that equation, so you can say that AC mu by 2 is your 4 now. So from here you can say that mu would be 4 into 2 by AC, that is 10. So mu comes out to be 0.8. So now this is how you find the mu here. So the above question and this question, so all the 3 questions I have given you the different ways to find out mu, because it's not directly specifying mu. In the first question it was directly specified, second question we had to use AM by AC, and the third question you had to use the general expression for AM to find out the value of mu. Now once you find out the value of mu, then the question becomes very easy now. So what is asking? It's asking you to find the bandwidth, PT, and the efficiency. So the bandwidth you already know that the bandwidth of AM would be that twice the bandwidth of the message signal. So message signal, you know, it is 400 hertz, so it would be 2 FM, or it would be 2 into 400, So the bandwidth of the AM is 800 Hertz. Then it's asking you to find PT. So PT, you know, it is PC 1 plus mu square by 2, and PC you can find out from the value of AC, which is your AC square by 2. So it again becomes 50 watt. Substitute the values of PC and mu here, and then you can find out PT. Then it's also asking you to find out the power efficiency. So again you can use both the forms, PSB by PT, or you can use mu square by 2 plus mu square, whatever you wish. Just substitute and then you can find out this. And the second part is it's asking you PC by PT. So again, you know PC, you know PT, you can directly substitute the values here, or you know that efficiency is equal to PSB by PT. So if I write PT as, I can write it as eta equal to PT by PSB, and then this I can write as PSB plus PC by PSB. So you can find out this becomes 1 plus PC by PSB. Okay, this is not eta here, this would be 1 by eta. You can find out PC by PSB from here. This is just a case when it's asking you to find PC by PSB, or you can just put the values simply here. No need to do all this and waste your time in this. It's just another method to find out. So you can find out at PC by PSB as 1 by eta minus 1 also. So that is how you can approach this question. So this question basically tell you about how to approach the question of AM, how to get mu from the question, how to find out mu. It can be specified, it can be hidden in the question. You have to find it out, and then easily you can apply all the formulas that we have studied. So that would be it for today's lecture. So make sure that you put all the formulas in your notes, solve a few more questions on this, go through the theory again, and then we'll move to the next lecture on the one day after. So the next lecture would be uploaded, every lecture from now on would be uploaded on alternate days. So the next lecture, I'll just give you a brief gist. Next lecture would be about the multitone AM. So we studied the single tone AM today, we'll study the multitone AM, and then we will see the methods to generate AM. So that would be your generation of AM. So I think we'll be able to cover these two topics in the next lecture. So thank you friends for watching this lecture today, and make sure that you subscribe to our channel and like our FB page for more such lectures and more such updates. And if you have any doubts, please mail us at snracademy.gate@gmail.com, and this is our FB page. Please like it, and you can also find out some interesting stuff on this page. We keep uploading some questions, daily quizzes which you can solve, and also we upload the papers for the upcoming exams. So make sure you watch them and stay tuned for further updates. Thank you friends, have a nice day, see you next time.